Topic 5.3, solving percent problems. Here's a great strategy to use when solving a problem to do with percents. Take the following problem. Grady is 13 years old and 155 centimeters tall. His height is about 90% of his final height. To estimate Grady's final height, we first look at the value that we're given in the problem. We're told that 155 centimeters is approximately 90% of his final height. So we pulled that information out of the problem. And we can determine what 1% of Grady's final height is by dividing the 155 centimeters we're given in the problem by the 90% that we're told it represents. And we get 1.722 repeating. So this value here represents 1% of the value of Grady's final height. And to figure out what 100% of his final height would be, we simply multiply this value by 100 to find that his final height will be about 172 centimeters. When we know what percent of the whole, of any whole, we can always divide to find 1%, then multiply by 100 to find 100%, which is the whole. Or if we wanted to find any other percent value, we'd multiply by that number. For example, if we wanted to know what 50% of Grady's height would be, we could have multiplied this value by 50 here instead of 100, and we would have gotten exactly half of this. Let's try a few examples and use that strategy. Number 1, find the number in each case. A, 15% of a number is 3. Well, whenever we're given a value and we're told what percent that value represents, we can divide to figure out what 1% is. So if we divide by 15, we'll find that 1% of this number that we're looking for is equal to 0.2. So I'll just put that here as a little note, a reminder that that is 1%. Well, now that we know what 1% is, we can multiply that value by 100 to figure out what 100% of that number is, which would be 20. So this number is 20. How about 1b? 160% of a number is 80. What is that number? Well, we can use division to figure out what 1% of this number is. We're dividing 80 by 160. 80 is actually exactly half of 160, so this would be 0.5. So 0.5 is 1% of the number. So we can now take 0.5, multiply it by 100, and find out that the number itself is 50. Or 50 represents 100%, or the whole amount of the number. How about question 2? Merrill sold 8% of the tickets to the school play. Merrill sold 56 tickets. How many tickets were sold in all? Well, we know that 56 tickets is equal to 8% of the tickets in total. So how many were there in total? Well, we can take the 56, which is equal to 8% of the total, divided by 8 to figure out what 1% is. And that would be 7. 56 divided by 8 is 7. So 7 represents 1% of the entire number of tickets, the total amount of tickets. So now we can just multiply that 1%, which is 7, by 100, and we'll find out that there were 700 tickets in total to begin with, which represents 100%. And how about the last question? Write this decrease as a percent. Illustrate this percent on a number line. The attendance fell from 9,850 to 8,274. So the attendance changed from this amount to this amount. So it started at 9,850 and it is now 8,274. So let's first find the difference. We're looking for the difference or the decrease. So 9,850 minus 8,274 is 1,576. Now it says to write it as a percent decrease. Well, the decrease was 1,576, and it decreased this amount from the original amount. So let's put this number over the original amount and see what that is as a percent. Well, if we divided these two together, the numerator by the denominator, we'd get 0.16. Okay, and to convert a decimal into a percent, we multiply by 100. So the decrease is 16%. And this can be illustrated on a number line simply by drawing a number line, 100% represented over there. This can be 0% over here. And the decrease was 16%. So 100 minus 16 is 84%. So this is a simple number line that represents the decrease in attendance.